Welcome to a place where design meets fun, where crazy ideas are the norm, and failure is just an exciting adventure, where the fun had and the memories made are the measures of success. Welcome to Ascend RC. Hi, welcome to Ascend RC. My name is Daniel. Today I'm going to talk about my radio-controlled submarine. I made this a number of years ago. It is really fast. It is a lot of fun. You can jump it completely out of the water. I went through multiple iterations of it. This is the version 2. Version 1 iteration was a bit smaller. I also had a different access port. I had cut access panels into the top of it and then molded some thermoforming plastic to actually fit. It was a real pain to actually get into to plug and unplug the battery. It was also short, so it was really cramped for space. So in version 2, I made it a lot longer, and I made a bunch of different sections on it that allow you to get into it a lot easier, and you have a lot more space. I did all the design work for this in CAD, in SolidWorks. I tested both versions in water. The first version did okay, didn't go underwater very well, and ended up having to swim for it one time.
And this is Daniel swimming after his submarine.
Version 2 testing actually did go quite a bit better. I did have to swim for it once, but I was able to really start testing out the maneuverability, the speed, and then I added FPV to it, and eventually added a GoPro camera to it. So let's go over what I actually did to build this. So, as you can see, it's rather long. There is a nose cone and a tail cone. These cones were made out of UHMW that I turned down on a manual lathe. I had the basic shape for the nose and tail cones designed in SolidWorks in CAD, and what I would do is I would hold up the template to kind of get what shape I needed to know where to take off more material with the lathe. And then I used a file to smooth it out and get a pretty good contour. There are 3 clasps on here to actually hold the nose cone on. I've got an O-ring that seals it. And on this one, I've already got I've got a probe on the nose of this. I haven't actually used it with the probe yet. That's to test out a few other things that maybe someday we'll actually get into, but for now I didn't actually run it with this. There is a hole all the way through the nose. So you run, water would come in through this, ram water if you will, come out through the port here. Then I would run through some tubes, and then I've got actual ports that go out. Those tubes would run through the motor to help cool the motor. They also ran through the electronic speed controller to help cool that as well. Not actually sure how well it worked. I would assume you get some good ram water through there. I never even pushed the system, so I was not worried about heating at that time. But anyway, this clasp system worked pretty well. As you can see, it was quick and easy to get it on and off. I really like that. Problem is it's clunky. You can see the clasps are large on the side. They're not really, nice to look at. They're not really smooth. They do create some extra drag. That's okay. We'll work on maybe redesigning that at some point. The middle section here, the front middle section, had, as you could see in the CAD, had a couple of plates in here that would hold the servos and also hold the battery locations. Then we have the fins with servo arms on them, and that's how we were able to control these. And these were acting as canards. Effectively, I set this up to fly like an airplane. As you can see, I like airplanes. That's kind of my background. Fly underwater. So it's a dynamic diver, so you have to have forward speed. It's positively buoyant, so if I stop, it will float to the surface, which is beneficial if you have control loss or power loss or hit the bottom, things like that. For the case in this one, I had to make sure to get the prop underwater. So because it's more of a torpedo shape, if the water line, if it wasn't high enough on the submarine, the prop could churn air. So you actually had to kind of pull back to like try to make the nose come up, which would make the tail sink to get moving, and then you could actually dive. But there's the front section. Then I had two middle sections, and these just held individual components. I think this section here was more for where the radio was, and the ESC. Here's the aft middle section. Again, this one has the water ports in there. You can see them on the side here. And then the tail section had the tail servos, and I believe I did 3 of those. I tied the rudders effectively together, and then did separate servos for the, I'm going to call them elevons, because they worked as ailerons and elevator. The roll was not very powerful. There was so much torque off the motor, you could roll it just by motor torque alone. And so trying to counter that was a challenge sometimes. I was not able to mix, I wanted to mix the canards in with the roll as well. Was not able to do that with limitations on my radio, but would like to do that in the future to give you more roll authority. There is potential to mix rudder in there as well for that, which would be very beneficial. So you'd have, effectively 6 fins controlling roll. Then you'd have your canard with elevator style pitch control with rudder control. Rudder actually worked the best for steering it. Pitch worked quite well as well. Then we have the tail cone here. Again, it's just a little bit different shape. It's got the hole in it. You had a bushing for the shaft to go through, and then the prop off the tail. All of these sections were held together with screws, and they just slide together like that. Aft middle section, front middle section. And I actually turned all these down on the lathe as well to get the stepped tube sections. So this is made from just 3-inch PVC pipe. So it's a 3-inch ID and a 3.5-inch OD. Worked quite well. Didn't have any problems with leakage with this system. So between each section, I put silicone seal, and then of course the O-ring on the nose section here. And it all worked out quite nicely. So let's go over what electronics I had in there. These were mostly from Hobby King. I was trying to go just as super cheap as I could, but they actually worked out quite well. As you can see, they're all out of the submarine, sadly. So this is the motor. It was an Aquastar 3660, 1460 kV. I'll show it to you there. Water cooled, so this is just a big boat motor. Good for up to 6S. So 1800 watts max output was what this was. Never ran it to that extent. We gotta run it to that extent at some point here. The speed controller, which I've kind of taken apart here, was a Birdie 100 amp boat speed controller. So a nice cheap one, but still 100 amp. Worked out well. I had no complaints about that speed controller whatsoever. Number of servos. Got a piece of steel for ballast. Got, who knows, that might even be lead for ballast. Again, I wanted to make it slightly buoyant, and you'd be surprised how much weight you have to add to make something the size of this float. Here's some of the tubes that I used. They just all plugged together. I had a Y splitter, split them apart to go one to the motor, one to the ESC, and then out the 2 side ports. Control. So, as it turns out, there's this great control system that we used to use called 72 megahertz. A lot lower than the 2.4 gigahertz that we now use with spread spectrum style radios. However, spread spectrum in that frequency, 2.4, anything that high, does not actually penetrate water. It's more microwave, so it excites the water and the water absorbs the radio frequency, the radio energy. 72 megahertz, however, is low enough that it's able to penetrate water. So I used an old airplane receiver and an old airplane 72 megahertz controller, 6-channel, to control it. Worked out well. I never, to my knowledge, hit the limits or extents of the control. I didn't go super deep. I didn't go super far. I think I was down past 10 feet though a couple of times and still had control. Problems are those radios are limited in their programming abilities, channel capabilities. I would really like to be able to take my Taranis and put a 72 megahertz module on it, or 27 megahertz, or what was the other one, 49 megahertz. So some of the already designated RC frequencies, obviously the lower the better penetration you would get. I would really like to be able to put that onto my Taranis. If anybody knows how to do that, get in touch with me and let me know. I'd really love to figure that one out. I've heard that it's a potential. I would like to look into that for the future. That would give us way more ability with setting up this submarine. So that's really it. Just servos, extensions. Let me talk about the FPV real quick. I just used a normal FPV camera that I had opened up and sealed, had that sitting on top of the submarine. I ran all of the power back into the submarine, so it was getting power from on board. Then I had a tethered cable coming out of the submarine that ran up to a buoy or a float that I pulled behind it. The reason you have to do that is what I just talked about with frequencies. All of our frequencies now for FPV, we're running 5.8 gigahertz. That does not transmit through water whatsoever. So I needed to be up above the water with the transmitter, at least with the antenna. I actually had the transmitter in the float and a separate battery there for it. So that was kind of one of the downfalls. You're pulling this float behind you. It's all right as long as you're not trying to go under sunken logs and trees and stuff like that. But anyway, that worked out all right. It was really easy or much easier to control and keep underwater when you did it with FPV than trying to do it line of sight. So just a normal boat prop. It was one designated for this motor. And then number of bearings. So this bearing actually ended up spinning, so I really need to find a little bit better bearing for the motor shaft itself. For batteries, I just use simple 3-cell, 4-cell. This one's the 4-cell, 3,000 milliamp hour packs. Worked fine with both, and it was just a matter of balancing it. You wanted it to be centrally balanced so that it didn't dip the nose, dip the tail. However, maybe if it dipped the tail, it would have been better. But I could run it up to 6S, never went that far, is to run it up to 6S. We got to do that in the future. This submarine hasn't actually run for over 3 years now. It's actually 4 years, coming up on 4 years since last time I actually ran it. I took it apart to make some modifications during the winter. It had some moisture in it, had actually gotten a little bit moldy, and never really got it put back together. We ended up moving, things like that. I really want to get it going again. It was a blast. Never got to test it out to its full extent. The motor can run up to 6S. Only ran it on 4S max and didn't even use full throttle very much. Just real short blips to full throttle. So it can be very, very fast. It was a ton of fun. I really enjoyed having FPV on it. It would have been really nice to get into a little bit deeper, clearer water. The water I had wasn't bad, but it was still difficult. There's a learning curve that I never really got through on how to, what do you want to call it, fly it, swim it. But I really want to get it going again. So hopefully in some future videos here, we can show you putting it back together, getting it running again for the second time, and yeah, having a lot of fun with it. So I hope you enjoyed this video. Thanks for watching, and we'll see you next time.